Why should you learn about this well-defined U-shaped curve called a parabola? Their applications are extensive. Think about a satellite. It takes weak signals from space, and any piece of information that hits inside of that satellite is then concentrated on this point called the focus, intensifying the signal. Think about a car light. The light bulb actually faces the opposite direction of where you need it to see. So then the parabola intensifies the light onto the road. So the strict definition is going to be the set of infinite points P in a plane. I'll use this down here as an example. That are equidistant from both a fixed point called the focus as well as a fixed line called the directrix. So every point on this parabola is equidistant from both the focus and perpendicularly from the directrix. So this equation is true. That the length of line segment from point P to point F for the focus is the same distance from that point to the directrix. Now the vertex is going to be the midpoint of the segment connecting the focus and the directrix. So it's right in the middle, and that distance is known as P. In the past, we've had the standard form for parabola as y equals a times x minus h quantity squared plus k, and now we're going to take that a value and exchange it with 1 over 4p, and then the plus k is just moved to the other side because it's a vertical parameter, so then it is going with the y value, which works with the dependent vertical value. The best way to work with parabolas is to visualize them. So I have these 4 graphs for vertically oriented parabolas when the p-value is positive, so no reflection over the x-axis. You then have your vertex, and then when the parabola is opening upward, the focus is always going to be inside of the parabola, so then you would add this p-value to the k-coordinate of the vertex because you need to go up. And then because the directrix is below, from the k-value of the vertex, you would subtract p to find the equation of this horizontal line. When you have p negative, you reflect over the x-axis, and now you take the p-value from the vertex, and you will add it to the k-value to get this line that's above the vertex. And the reason why it's saying k minus p here is because technically p is negative, so then subtracting a negative would get you that addition, so it would move you up vertically. But I always, when I talk about p with the graph, I am talking about its absolute value. And then because the focus is inside the parabola when it's opening downward, then I would have to subtract p from the k-coordinate. So that's everything when you have a vertically oriented parabola. That's when it's like a y equals. When it's x minus h equals, so when the x is the dependent variable and y is the independent, then it's going to open to the right when p is positive. And then to get the coordinates of the focus and the directrix, you take the p-value and you add to get to the focus, you subtract to get to the directrix. And that's with the h parameter. And then when p is negative, you're reflecting over the y-axis. So then the focus is to the left because it's always inside the parabola. So then you go from your vertex and you would subtract p to find the coordinates of your focus, and then you would add p to find the equation for the directrix. Please make a note down here that the absolute value of p gives the distance from the vertex to both the focus and the directrix. When given the graph of a parabola, you can look at key pieces of it to write it in standard form. So first of all, we could look here and see that we have the equation of the directrix is y equals negative 1/2. The coordinates of the vertex are at the origin. And so what that means is the p-value is going to be the distance between the k or y coordinate of the vertex and the horizontal line, the directrix. And that distance is equal to 1/2, and you could find that using this equation, y equals the k value minus p because we're going down, and then you get the y value is negative 1/2 at the directrix, and then the k value is at the origin of 0, and then when you solve for p, you see that it's 1/2, but it's just better if you can size it up visually. Don't worry about memorizing these kinds of formulas, just know how everything is related through the p-value. So next, it's essential to know which standard form to use. So looking at the graph, we could see that this is an upward opening parabola, so we want the vertical standard form. And with this standard form equation, we will now substitute in the known values to write the standard form. So I substitute in the origin coordinates, 0, 0, and then I substitute in the p-value of 1/2, and I simplify. And there's the answer. The next problem is different because we're given a description of the coordinates of the vertex, hk, and we're told that the directrix is x equals negative 6. So we need to create a abstracted version of this graph that shows the key features. Because it has a directrix at x equaling negative 6, that is a vertical line. So therefore, this is a horizontal parabola. Think about the directrix as like a launch pad of the parabolic rocket. So we would have the following sketch of what the graph would look like. I have drawn the directrix to the left of the vertex because the x value is negative 6. Remember that the distance between the directrix and the vertex is the p-value. And so its absolute value is equal to 6 because that's the distance between x equaling negative 6 and x equaling 0. And then I could use that to also find the focus coordinates if I needed to. So now that we have the p-value, h and k, and also we could see that this is a horizontal parabola that opens to the right, so p is positive. We could pick the correct standard form, substitute in the values, and come up with the equation. Please make note that in the standard form, it's always the opposite of h and k. Substituting in the origin, substituting in the p-value, and then simplifying to come up with the answer. The last two examples will focus on going from the standard form to finding all of the information about the parabola and then using it to graph. So let's dissect the first example standard form of a parabola. So I know it's a vertical parabola because it's a y minus k equals. And because this value here, 1 over 4p, is positive, I know it's going to be a parabola that opens upward. Now be very careful when finding the coordinates of the vertex hk. K is always with the y and h always with the x. So h will come from here, and remember it's minus 2, so it's actually the 2 that's the h, so it's positive. And then this is really y minus negative 3. And you got to remember that the standard form has those subtractions in it. I know that 1 on 8 is supposed to be where the 1 on 4p is. So I could just ask myself, what do I multiply 4 by to get 8? And then the answer is 2. Or if the math would be more difficult, you could cross multiply 4p equals 8 for p equaling 2. Next, for the axis of symmetry, it's a vertical parabola, so it's going to be a x equals vertical line that runs right through the x-coordinate of the vertex, so it's x equals the h value of 2. I will continue to visualize what's going on with this parabola now to find the focus and the directrix using the p-value. So I visualize the upward opening parabola. I know the p-value is 2, so that means that the focus needs to be above the vertex by 2 units. So that is going to be changing the vertical part of the vertex by adding 2 to the y-coordinate and getting 2, -1 for the focus's coordinate. Now the directrix is going to be below, so then I need to take that p-value of 2 from the k-coordinate of the vertex and subtract it. So then I have a horizontal line of y equals -5, and now we could use this information to graph. I start by plotting the vertex, followed by the focus, labeling each v and f respectively. I always want to make sure not to confuse the two, because that could flip your parabola upside down. And then I graph the directrix, I graph the axis of symmetry, and then let me talk about how I chose this point. You could choose any value for x. You just need 3 points to define a parabola. You get 1, and then you could reflect it the same distance across the axis of symmetry. I chose 6 because I don't want to plot a number with fractions, so I asked myself the question, what minus 2 squared is divisible by 8? And I thought of 6. 6 minus 2 is 4, squared is 16, divisible by 8. So you could just pick any point because you just need 3 for a parabola. Let's take a look at how this parabola will work out, given that it's an x minus h, so then it's going to open to the side. Now you could take a quick look. It's a horizontal parabola, p's positive, so it's opening to the right. And then you deduct all this information, graph, finding a y value that when you add 1 to it and square it, it's divisible by 2, solving for x is 4, reflecting that to complete the problem.